Okay, welcome back. Okay, now we are going to talk about optics first. Okay, before I go to kinetic model, one of your classmates was asking me about the proof for the relation I was talking about in class. Okay, if you forgot what relation is, the relation between the lens and the object and the distance of image to the lens. Okay, particularly V and U, which I'll explain to you in a while. Okay, now, yeah, sorry about the delay though, because there's some issue with my mic. I think this is the best mic I can find at home. Okay, I hope it works. Okay, if it doesn't, just let me know on Monday when you see me in school, or you can comment below in the section. Okay, so yeah, back to the lesson. Yeah, we are talking about how the distance between object and lens and image and lens differ from one another. Okay, and this was a conclusion that was brought up in class. Okay, now suppose I have a lens here, right? Let me shoot the pen. Suppose I have a lens here. Okay, and this is the principal axis. Okay, now if my object is to go towards the lens, okay, we were saying in class that the image will go away from the lens. Okay, now if we were to define the distance from object to lens, okay, so this distance here, let's call it by u, and this distance here, let's call it by v. Okay, now if we were to define it like that, okay, as you can see in the box over here, I'm going to erase all these first. It's quite messy, right? Yeah, then we do realize that as as u decreases, okay, as it approaches the lens, okay, therefore it decreases, v increases. Okay, so this is the relation that we draw. Okay, of course the opposite is true, saying that u increase, then v has to decrease. Okay, so this is the relation that we see. Okay, now regarding this relation, there's actually an equation that I think Mr. Lee has talked to you about in lesson that day. It says that 1 over v plus 1 over u equals to 1 over f. Okay, and as we know, this f here is a constant. Okay, so therefore this is an constant. Okay, 1 over, since f is constant, then 1 over f has to be constant too. Okay, because there's no other variable. Okay, so I'll just show you a simple working, okay, of this formula you see over here. 1 over v plus 1 over u equal 1 over f. Now let's look at a photocopier. Okay, now the location of object is at 2f. Okay, as you can see over here. Okay, this is also written here, and the location of image is also at 2f. Okay, now if we were to give a value to the location of object and location of image here, then we would say that the image distance v will be 2f. Okay, since it's at since it's the image is at 2f point. Okay, and we will say that u equals to also 2f, since object is at 2f. Okay, now if we were to use these values, okay, these values over here, and we will submit into this equation, okay, what you'll get is let me write it in red. All right, 1 over 2f plus 1 over 2f. Okay, and this will give you 2 over 2f, and you cancel the 2, you get 1 over f, which is this result that we expect, and 1 over f is indeed 1 over f. Okay, and we have shown that this equation works. Okay, so it is true that when your object is at 2f, okay, your image has to be at 2f in order to fulfill this equation. This equation here is always true, okay, for all cases. Okay, now through this equation, right, I want to show you this relation as well. Okay, so it's not magic, okay, it's just math. Okay, now 1 over u plus 1 over v is 1 over f, and we say that this is constant. Okay, now if this is constant, then 1 over u plus 1 over v must always give you a same value. Okay, now if this was the case, then let's say for example 1 over 3 plus 1 over 4. Now okay, maybe this number is a bit bad, let's use 1 over 8 instead. Okay, so if my v equals to 4 and my u equals to 8, okay, then we have 1 over u as 1 over 8 and 1 over v as 1 over 4, and you know that this will give you 3 over 8. Okay, now suppose my object goes towards the lens. Okay, so u will now become 6. Okay, as it goes towards the lens, the distance is lesser. Okay, so a particular diagram looks something like the object is going towards the lens. Okay, so u is now 6, and my v has to be definitely greater than 4. Okay, more than 4. Okay, now if we were to work it out, 1 over 6 plus 1 over v is 3 over 8. Okay, now 1 over v would then be 3 over 8 minus 1 over 6, which 4 definitely is uh, lesser than 1/4. So in other words, v must be greater than 4. Okay, remember that for a fraction, the larger the denominator, the smaller the fraction. Okay, so it is true that this is v, this is u, and as the object approaches the lens, the image goes away from the lens. Okay, so this is how the equation works, which will actually draws us to this relation. Okay, this relation here is crucial. Okay, in the case of you forgetting this relation during exam, yeah, please I hope you remember this equation. Okay, because this equation will lead to this relation. Okay, mathematically. Okay, yeah, give me a moment, I'm going to erase my screen. Okay, for those who are not interested on how this equation that I'm erasing right now is being proved, okay, you may stop the video here. Okay, the idea is just to further show you mathematically how what we discuss in class works. Okay, now for those who are interested in the proof, okay, please hold on for a few seconds. All right. Okay, now over here we're going to prove it using geometry. Okay, similar triangles. Okay, it will look something like this. Okay, yeah, so let me show you. Okay, now suppose I have, okay, I'm going to draw my object in green. Okay, so suppose I have my object here. Okay, so you know that the first line that you draw is always this diagonal line. Okay, I'm going to erase these two, sorry, hold on. Okay, I'm going to go a bit faster. Okay, now suppose I have this diagonal line here. Okay, and I have the next line here. Okay, and we know that this has to pass through F. Okay, and we have this. Okay, this is our image point, this is our object point. Now for the I want you all to look at two specific triangles. Okay, two pairs of specific triangles. This pair here, okay, the one in red. Okay, maybe it's not that clear, hold on. Oh crap. Okay, we have this triangle here. Okay, and we also have this triangle here. Okay, now you know that this is v, okay, and this is u. Okay, the image from the object to the lens and the image to the lens. Okay, and we want to call this h prime. Okay, and we want to call this h. All right, now with this we can actually also know that this angle here is the same as this angle here. All right, and using your trigonometry, okay, for the red triangle, you realize that, okay, let's call this alpha. Tangent alpha is equals to Tokaso, right? So opposite over adjacent, you're gonna get h over u. And for the blue triangle, tangent alpha is equals to h prime over v. Okay, so basically what we have at the end, combining these two equations, is h over u equals to h prime over v, which actually gives us h over h prime equals to u over v. Okay, now this is equation 1. Okay, there's another equation that can be found in this diagram. Okay, I want you all to look at another triangle. Okay, the next triangle that we will be looking at, as you can see in this diagram here, okay, it's this triangle here.